All right. So today we're going to use a cubic function to model a situation. I said this at the beginning of the year. I don't know if you guys remember every little word that I say to you. You don't? You guys, wow. So, anyways, model. I'm recording, by the way. I'm recording. Um, so a model. When we say model, we're talking about a mathematical equation that fits to data. So everything that we use math for in the real world is we collect a bunch of data, we graph the data, we look at it, and we go, oh, this looks like a parabola, or oh, this looks like a linear function, or in this particular case, a cubic, right? So a couple things I want to talk to you about the cubic, and I want to front end load this, and I haven't really been doing it as much, but a cubic is the parent function is just x to the third power. So if I think of a function, f of x is equal to x to the third power, we would say x cubed and or x to the third power. So a cubic is an odd power of x. 3 is an odd number. So odd powers of x come in from the bottom and go out the top if they have a positive leading coefficient. Okay? So it kind of looks like that. Now it varies. That I should probably do a little bit better job on my graph. It really x cubed looks more like this. I was just drawing an example one, but it goes through the origin. It's symmetrical about the origin, and it looks like that. Okay. So if we collect data and it kind of looks like this, then we can make an equation, a cubic equation, to fit the data. And that's what all the transformations and the H and the K and the vertical and horizontal shifts and the stretching and compression, that's just so we can make that line or curve fit data. Once we have that equation, then we can make predictions. Okay, so that's what we're going to do here, and we use the word model for all that stuff. So here it says that estimate the length of the edge of a child's alphabet block or a cube that has a mass of 23 grams and is made from oak with a density of 0.72 grams per centimeters cubed. Okay. And let me scroll up so you can write this table of values as I'm talking. It says let L represent the length in centimeters of the edge of the block. Since the block is the cube, then the volume would be L cubed, right? So it's L times L times L. And the mass of the block is 0.72 times the volume of the block, which would be 0.72 liters cubed. And then it asks for us to make a table of values. So we made the table of values. Okay. So I'll leave that up there for a second while you guys are trying to copy all that stuff down. I'm going to repeat all this again because I think you guys are trying to write it down as I was talking. I just want to make sure we're all on the same page here. I'll just be quiet and let you guys finish writing that down. So basically, you have an x and a y value, right? And if we graph that x and y value, we have an x here, we have a y value here. We could call this g of x or v of l, whatever you want to call it. But that represents something, okay? And so the next thing they ask us to do is draw a graph of the mass of the function, recognizing that the graph is a vertical compression of the parent cubic function by a factor of 0.72. So what they're saying is, and let me clarify this. I have the original volume, right? The volume as a function of L is equal to L cubed. Now what that means is, think of f of x is a function, f is a function of x cubed. So this is the same thing, except we're using v as the title of the function v, which is a function of L, which is equal to L cubed. Then they're telling us that we have the mass of the block, which is equal to, let me write that in a different equation, the mass of the block, which is also a function of length, but that's equal to 0.72 times L cubed. So we have this number in the front. And what they're saying is when you graph it, it vertically compresses it because 0.72 is less than 1. So my y value is going to be about 72% of what the original y value is. And keep in mind that the length helps to determine the volume, and in essence, the volume helps to determine the mass because of the density. Okay? I see some confused looks on your faces, but I'm going to scroll this up so we could take a look at the graph. Okay? Just take a look at the graph. Maybe all the density, mass, volume stuff is overwhelming, but basically density is how much stuff you have crammed in a certain amount of space. So the density is going to be how much mass you have in a certain amount of volume. We can measure that. And so what they're doing in this particular problem is they're saying, well, the length of this object helps us to calculate the volume. The mass of this object is based on the density. So when they do all the math, we still have a cubic function that's transformed from another cubic function. I don't know if that helps you or not. So then what they want us to do is a vertical compression of the parent function by a factor of 0.72. It says, then draw a horizontal line at m equals 23 and estimate the value of L where the graph intersects. Okay, so go ahead and sketch that out. I'm just waiting. I'm watching you guys as you sketch things out, giving you time to finish writing everything down. In other words, this is what the table of values are when you graph them. They want to know when the mass is equal to 23 grams, right? And based on the density and the volume, because this is the length, right? We can figure out the mass based on the length because we've transformed this function here. And so what we do is we go, okay, well, what's this intersection about what is the length? Okay, so we're trying to figure out what the length is. How big of a block? So this is a very common thing done in manufacturing. There was a toy company. They want to make baby blocks, little alphabet blocks for babies to play with. They need to know, for shipping purposes, they want each block to weigh 23 grams. They know the density of the oak wood, so they can measure the length. And based on the length, they can approximate how heavy the block will be. Does that make sense? So they're working backwards to figure out, probably because they have to ship the blocks. And so it is exactly what I'm teaching you. It's a transformation of a cubic function. So then what's the next step? Well, it looks, if you were to guess, where do you think that intersects at? So I'm going to give you a clue. This is about 3 here, right? So I would say that the length is probably about 3.2 centimeters. So let me change this. Instead of saying it equals, what do I put there? the squiggly equal sign, which means approximately 3.2 centimeters. Well, that's the length of it, and that's basically it. Okay? That's all you have to do. Any questions on that? And I wrote it down, but it says so here. So let me zoom out so you can see everything, and I'll recap. Essentially, what we're doing is we're taking, and by the way, this is just the first quadrant, right? So if you look at my graph that I sketched out over here, this is f of x equals x cubed. What they've done is they've just taken this first quadrant. This right here is just the first quadrant of a cubic function. Okay? And they said, well, look, based on the density being 0.72 grams per centimeter cubed, they're working backwards to figure out. They want a block that weighs 23 grams, and they need to figure out how long the cube needs to be, right? And that's it. That's all they do. So the transformation was the mass is equal to, so what they did is, this is a vertical compression of the original function of the volume. And basically what we're doing is we're calculating the mass based on the length of the object, of the cube.